Okay, kids, this is Processes and Materials of Technology. Basically, we're going to go over all the materials you're using. You already started your wood projects. We're going to start our metal projects next week. Um, but we're going to go over what materials, how we get them, what they are, what are they, what can we do with them, how we create them into nice products, and so on. So, first, I want to know what engineering materials are. Well, think about it, there are materials that are physically turned into products. Um, we have engineered materials, standard stock industrial materials, and production materials. These pictures show lumber. That is materials that we create. Standard stock, you can go to Home Depot and create them. Again, these are engineered materials that we produce them from our raw materials to create, to be able to create something with them. If you notice this sheet of metal being turned, this comes from our metal dug up from the ground. We melt it and put it into this little sheet. That is a industrial material. It can be considered a production material. Depends on what we're doing with the metal. Okay, last photo here is plastic. Again, we have wood, plastic, metals that we tend to go over the most of, and all these are materials that we make into products, and these materials are those four listed. Where do we get them? That's one question that comes up. How do we get our materials? Well, if it's something that comes from living things, we call it organic material. Wood comes from a living tree. Wool comes from, you guessed it, sheep. Okay, so that, again, living creature. Silk, rubber, there's all kinds of different organic materials out there, but it comes from a living thing. Inorganic materials comes from the earth. Okay, something that we have to, that is not. I mean, there's a big sense that it's not living. Well, people argue that metal used to live. It's just been a long time ago. Well, in today's world, if it can't live and for 15, 20 years, in some cases trees can go up to 100 years, and then we have to replant it or regrow it or whatever, it is inorganic, so it has to be able to be reproduced, such as the organic materials. So metals comes from our mineral deposits that we dig up out of the ground. Two ways to get these materials is extracting and harvesting. Okay, if we're going to harvest them, basically we're going to harvest organic materials. Okay, we grow trees to cut them down, we harvest them. Okay, we grow our crops, we harvest them. We grow sheep, we harvest them. Now, inorganic materials, we are going to extract them. Okay, we're going to extract them from the earth. Coal mining, that's what this area of the Frontenac and Pittsburgh is known for, is our coal. We dug those out of the ground. That's what we call extracting. Okay, so digging out of the ground is extracting. Taken from the earth that we cut down, that's called harvesting. Okay, materials that we commonly make products out of. Polymers. Okay, poly means many. MERS, polymers is many MERS. Okay, we have metals, ceramics, and composites. Composites are made up of two or more items put together to make a stronger product. Ceramics is one of the oldest products known to man. We get out of the earth. Metals, again, we pull out copper, we pull out brass, we pull out all these different metals out of the ground, and we extract them and use them. Okay, here's some polymers that we're going to talk about. Again, there's two types, synthetic and natural. Our natural polymer is our wood, wool, cotton, silk, rubber. These are just examples. Again, anything that we can grow ourselves or produce or raise, these are all going to be our natural polymers. Synthetics are the things that we have to make. and that is our thermoset plastics, our thermoplastics, elastomers, so elastic. Here's some examples: of plastic milk jug, the plastic on our electrical wiring. These are all types of plastics that we hear of, and these are synthetic plastics. Synthetic meaning man-made. Most of them are made from natural oil, or not natural, excuse me, from oils that we use. So shows the example: when you burn plastic, it's tend to be black. Same as when you burn oil, or if you see in the Middle East, when all the oil refineries are on fire, big black smoke, and they tell you not to burn plastic because you are literally burning oil, polluting the earth that way. But there are natural polymers, which are wool. There's these examples you see on the left here. Okay, wood. We're gonna go over wood and classifications of wood today, and then we're gonna call it quits. This is a long PowerPoint, but we'll break it up into 3 different ones. Wood. Wood is determined by the type of leaves, not the actual wood itself, but the type of leaves. And there's 2 types you've learned through school. You have hardwoods, or we call those deciduous: oak, walnut, maple, cherry, balsa, poplar. There's all kinds of different maple. There's teak. There's, guys, you can go on and on. There's tons of different woods. In college, we had to actually memorize 60 different woods, not by the leaves, not by the trees, but their cell structure. And it was kind of a fun project, but there's so many trees, species out there of these 2 types. It's unreal. You get hickory, pecan, there's just a bunch of them. Again, they come down to the 2 groups: deciduous and conifers, or softwoods. The softwoods, again, is pine, cedar, and Douglas fir. If you look on the left photo, it looks like more of a Christmas tree. If it keeps the leaf or the needle all year long, those are going to be your softwoods. If the leaf falls off in the winter, that is going to be your hardwoods. So if you go down the road this winter and you see no leaves on the tree, you know it is a hardwood. Therefore, if it has needle-like leaves and it's winter time and they're all there, it's green, you're going to know that is a type of softwood. Okay, so that's how you determine the wood type, is between the two is because of the leaves. Okay, you need to know a little bit about woods. Wood is made up of a couple things: cellulose and lignin. Cellulose is the fibers inside wood, and lignin is almost like the glue. The glue inside holds the wood together. Okay, so if you think about it, if you put your hands together, if you put them together, fingers interlocked, and you loosen them up, the lignin actually is, when it gets loose, okay, sorry for the interruption. I had somebody come in the door, so I'm going to start back over. We have talking about cellulose and lignin. Cellulose, again, is the fiber of the wood itself. The lignin is the glue. It holds everything together. Now, think about the rounded boards or round oak tables. You see this a lot. You see wood that is bent. Lignin is since it's the glue, we can actually bend wood. In college, we actually bent it into a pretzel shape. We took a board, we loosened the lignin up, which is the part of the board that keeps it hard. We loosened it up and was able to bend the board into a pretzel. As soon as that lignin hardened, that board became stiff again in the shape of a pretzel. It was a kind of a neat thing, but if you understand, there's 2 parts. The part that is the fiber itself and the glue, which is the lignin inside of it, there's 2 separate, and we can kind of control those. We can steam bend wood by steaming the lignin and making it soft, or we can use a chemical, and that's what we use in college, a chemical to create the lignin to get soft and bend. So just if you ever want to know that you can bend wood, yes, it's true. You can. Moisture content, very, very important in wood. When we talk about wood, moisture content is the amount of water that is in the wood. Here in the Midwest, we have quite a bit of moisture. Go to Southern California, there is absolutely no moisture in the air. Therefore, there's no moisture in the wood. You go down to South Florida, there's a lot more than we have. Now, with that in mind, if you take furniture from Florida, drive to California where it's completely dry, your wood structure will tend to kind of fall apart, blow up, bust, crack. There's all kinds of problems that come with this because of you have something with a lot of moisture in it. And think about your fingers. When you get really hot and sweaty, your fingers tend to swell. Same with wood. It shrinks and swells according to the moisture in the wood. If there's a lot of moisture in it, it's going to swell up. For example, down in Florida, then you drive to the desert of California, it's going to shrink that wood and pop all those glue joints that you just created. So moisture content is very, very important. You have to account for it whenever you produce products. If you don't, you'll have a disaster on your hands. Here's some types of wood products that we're going to talk about, and I'll show you in class what they are. Sawed lumber, plywood, MDF, which is medium density fiberboard, OSB, oriented strand board, and particle board, little bitty particles of board. And we have all these so we can save every bit of the tree instead of wasting any. Okay, that's going to end our lecture today over generic building materials, engineering materials, and we got into the section over wood. Again, I'll show you in class the different types so you can see the physical product in hand, and then the next video we're going to talk about is plastics. See you in class.